this video we're going to go over a concept closely related to solutions and solution calculations, and that is dilutions. So dilutions are the process where the concentration of a solution is lessened by the addition of more solvent. And so this is a common means of preparing solutions to a desired concentration. In stockrooms, it's not practical to have all the different concentrations of a solution that we might need, and so in order to save space, we often have more concentrated solutions. So we call these stock solutions. And then when I need a solution with a lower concentration, I can just dilute it by adding more solvent to it. And so when we start with a stock solution, it's more concentrated. So there are more solute particles relative to the solvent particles. When we add more solvent, we're decreasing the ratio of the solute particles to the solvent particles, and so we're resulting in a lower concentration. Now, an important feature of dilutions is that when we add more solvent, we're increasing the volume of the solution and we're decreasing the concentration, but the moles of solute don't actually change, right? The solute's not leaving, we're just adding more solvent. And so if we think about the molarity equation, both before we do the dilution and after we do the dilution, the moles, which is the molarity times the volume, doesn't change, right? So the moles before, or N1, and the moles after the dilution, N2, are going to be the same. And so we can use the fact that if N1 and N2 are equal to each other, then we can set M1V1 equal to M2V2. And so this gives us a very useful equation for doing calculations that involve dilutions, where M1 is the initial concentration, V1 is the initial volume, M2 is the final concentration, and V2 is the final volume. Now we're doing this with molarity, and so I'm using M and V, but when we learn other types of ways of measuring solution concentration, we can do the same thing with those. And so a more general way to write this might be C1V1 equals C2V2. So whatever concentration unit we have, if we multiply that by the volume, that's going to be equal to the final concentration times the volume. It doesn't have to be molarities. All right, so let's see an example of what this might look like. So I have 0.85 liters of a 5 molar solution of copper 2 nitrate, and it's diluted to a volume of 1.80 liters. And I want to know what is the molarity of the final diluted solution. So they're asking me for M2. Right? And the volume of that diluted solution is the 1.80 liters. So they've given me V2, right? They also gave me the initial volume, and they gave me the initial concentration. So when I look at M1V1 equals M2V2, right, this is essentially my X. So I want to get that by itself. So what I'm going to do, divide both sides by V2. And so our final concentration should be M1 times V1 over V2. All right, and so I can go ahead and put my numbers in. And so my initial concentration is 5 molar. My initial volume, 0.85 liters. My final volume, 1.8 liters. And so you can see the liters cancel, and my units will be molarity, which is good. Another nice feature of this M1V1 equals M2V2 equation is normally when we do calculations with molarity, the volume always has to be in liters. But as long as we use the same units for both the initial and the final volume, they're going to cancel out. And so if we had started with milliliters, I wouldn't have had to do the conversion, because if I plugged it in milliliters and plugged it in milliliters, those would have canceled for me. It's always good to check and see if our answers make sense. So before I even finish this calculation, I know that I'm diluting my solution. I'm increasing the volume by about 2, and so my new concentration should be about half of the original one. And so we can check our answer and see if it makes sense based on that rationale. And so when I do that math, I get 2.36 molar. And so that is about half of the starting concentration. So I think that result makes sense. And so that is our final answer.